having got that concrete shell, we then connected, shot fired onto that, to the shell, the polystyrene insulation that separates the shell from the external environments. And onto that we established a series of woven lines driven by the architect to extend this cocoon analogy, but those lines also lent themselves to movement joints in the polished plaster. So really we just had to be prescriptive as engineers in terms of the size of those panels, the maximum dimension of the panels, and the architects could then go away and create this cocoon that enabled the movement of the plaster to occur. An interesting story is the way those lines were generated. Because it's a doubly curving shell, as I was saying, the beads that form those movement joints naturally don't want to be bent in two directions, because then they start warping. So in order to ensure those beads were curving only in one direction, we used a program, a bolt-on bit of software to Rhinoceros called Toy Car. The idea being that if you were to be on a hilly terrain in your car, you were to lock the steering and you were to press the accelerator, you would disappear off into the horizon, but there would be one path that you would take, and that path would always be a singly curving path. So we used this bit of software to generate these woven lines, and obviously the architect had to ensure that the doors were occurring in the right positions. But as long as he gave the maximum, he stuck to the maximum area requirements for the shell and the maximum dimensions. As long as he stuck to the maximum area of each panel for the polished plaster and the maximum dimension, he had free rein to do what he wanted.